normal data. Why do we do this? Do you remember why we need to have this conversion? Why I wrote a program and it's called STNormal? Why not just have a program for every bell curve?
Because this makes it all kind of fit to that one scale.
Yes.
It just simplifies the process.
Exactly, Alicia, because how many scales are there?
Infinitely many.
Infinitely many. A data set can have one of infinitely many averages, and each of those averages can have one of infinitely many standard deviations. And that's a problem. I mean, technically speaking, you could make the program calculate it each time as you go, but that makes the code even longer than it has to be. This way, you take whatever your data comes out looking like, we call it X in general, random variables are X, and you normalize it down to this Z, and those data points will have an average of 0 and a standard deviation of 1. That's another one of those moments in my intro stat class where I said, why? Why is the average 0? Why is the standard deviation 1? If you're interested, there are tons of enrichment documents on this last 3 weeks of the term. Because there are so many questions you guys might be asking, like, I don't get it, why it's 0 now? Why is the average 0 now? Why is the standard deviation 1? If you're interested, I got justifications for all this stuff on the enrichment page. If you're having a hard time thinking on Thanksgiving night, need some documents to knock you out of sleep, the enrichment page is full of them. So, anyway, they're there waiting for you if you need them. So I want to put this to use. Yesterday we played with IQ, and we did the superior one, I think, right? We did the superior, then we did the 10th percentile, and I think we left it at that. So let's get out of that, and let's go to human pregnancy. So 2 more topics, then we'll call it a day. Human pregnancy, and also speed limits on I-5 in Portland. Okay, so here we go.
Do we have those?
For a while, they took them away in Montana. Remember that? They took the speed limit away in Montana for a while. They made it like the Autobahn in Germany. And the problem, well, we'll come back to that. Anyway, well, there's a big problem that nobody caught, and I can't blame them for not catching it. We'll come back to that, though.
No, you can finish your thought.
We'll come back. We're gonna go ahead and read this. Read this. What's in that? What did I do? Oh, that's messed up. So I want to look, if you will, at the, I guess, the outlier. I want to look at gravity. I want to look at, thank you very much. The table's over. The outlier considerations of pregnancy, the ones people talk about. Very often you won't hear about how pregnancy goes completely normally. You'll hear about the weird conditions, like my wife was in labor for 12 hours, like, you know, that kind of a thing, exactly. It's a lot of slow dancing. So I want to talk first about the preemies. Now, I have never gotten a firm 100% agreeable definition of what a premature birth is. However, the modal definition of what a premature birth is, the shortest 5%, the 5th percentile, is the cutoff for what makes a birth a preemie birth. That's the one I read about the most in scientific literature, and when I talk to midwives, they're like, yeah, we've heard that one too, we'll go with that one. So I want to figure out, that's great, except how do you tell a mother what that is? Like, you're like I'm in labor, I'm worried about it being premature. I'm like, are you in the 5th percentile? Like, first of all, she's gonna punch you right in the face, as she should, right? She should punch you right in the face. But the question is, assign a number of days to that. Like, when was your conception date? Because that's what first you have to figure out is when you think your conception date was. And then give her a number of days past that. That's the cutoff, right? What I want to know is, what is the cutoff date for preemie births? Not a 5th percentile, but what is that as a day? Michelle, go!
I was really preterm with both of mine, and I was told that it's if they're born before 37 weeks.
Let's see if this... That's a forwards, this is a backwards.
Okay.
I'm giving you an area on a curve, you've been given the actual label on the curve. So let's figure out if those jibe, yeah? Good. Now I don't have it weeks, I have it days, I think. Yeah, 266 days with just over 2 weeks, so 16 days. Let's set the curve up. Yeah, I like that. Thank you, Michelle, for bringing that up. And the next one's even better, because I almost got to piss out with the midwife over the next question. One of my favorite questions in 243. She's like, no, you're wrong. I'm like, okay. Let's put the chair down. It's just one. So there's 0. So this is the general, this is the STNormal curve. we need to get to this curve. So this guy has a 1, he's got a 2, he's got a 3, he's got a -1, and so forth. What are those guys called? Those labels on the horizontal? Good, z-values, z-scores, love it. Good, there's z's. What do they actually represent? Like, what does this represent right here?
Standard deviation.
Good, that's one standard deviation is within there.
2 standard.
3.
Beautiful. So you've got all these wonderful standard deviation measures. The problem is, we know those 3 percentages, right? What percent are here?
68.
Good. 68? What percent are here?
95.
Good. What percent are here?
99.
Good. And we've had those for weeks, right? We constantly discover those percentages. The problem is, what if you deviate from those standard deviations? And that will often happen when you're analyzing the extremes of the population. For example, preemie births. Preemie births are not in the middle. This is where the normal births are, quote unquote, normal
Right.
births, right? Here's the average. Here's the average range, if you will. Preemie births are down here. So the trick is, we gotta get this curve to be meaningful to mothers by transferring it down. 0 isn't gonna be 0 when you're talking to a mother. It's gonna be 266. Plus or minus the standard deviation is gonna go up to 16, up 16 or down 16, right? So up 16 is going to give us, is that 282? Did I do that right?
Yes.
I think I did.
Yeah.
And then down 16 is 250? So that's one standard deviation. So the middle 68% of births should be between 250 and 282 days. According to these parameters, which I've gotten from medical journals as well. If we bump it out to 95%, we got to add 12 more, which will be 294?
So you gotta add 16 more.
16 more, 298, thank you. Is that 298, I think? Then 234. And then we go even further, we go 16 more. Not that I wish any mother on earth this, but 16 more would be 264? Oh my god.
3 something.
Sorry?
3 14.
Oh, that's a 9. Can't read my damn writing. That's 248. Thank you for being patient with me. That's almost a year of pregnancy. I know.
Oh,
It's just like,
thank you.
Jesus. And then down 16, 3, 2,
The year's not that
18?
off.
Did I do that right? I don't trust my math anymore. So now the question is, these are all days of pregnancy. Now, many of them are interrupted by induction, right? Like, for example, I doubt very much we're going to let a mother go 11 months before having a baby. So it's induced, which we're gonna deal with that in the next question, the induction question. But the question is, where's the preemie cutoff? Is it 218? Is it 234? Is it 250? Well, you know it's not 250.
I'd say 234.
Because if you cut it off at 250, what percent are now preemies? It's a fun question, isn't it?
When
If you cut it at what did I say, 250?
Yeah.
If you cut it at 250, that means you've cut it right here, correct?
Yeah.
So what percent are now preemies? Well, you got 68 here, correct? 68 here, that means there's 32 here and here.
So it would be
So that's 16 over here. 16 and 68 is going to be, is that 84? I think 84% is over here. That means you got 16% preemies. Well, that's too much. We only want 5% being preemies, right? Does that, you see what I'm saying? That I did that kind of quickly, but you can use the normal to do that too. So should it be 234? Well, let's think about that. 234, that's 95%, correct? That means there's 5% left, 2.5%, which is over here. 2.5 plus 95 is 97.5. So Alicia's nailed it. This is too far down, this is too far up. Somewhere in here is the correct z-score that actually chops 5%. This chops 2.5, this chops 16. Somewhere between those two is the correct one. Aaron,
So
please.
is it 1.5 standard deviation?
Let's not guess, let's figure it out. That's the thing, we can keep guessing until we get the right area, right? And so, in other words, we can keep guessing at forward problems until we get the correct answer, or we can make this a backwards problem. And do you see why it's a backwards problem?
Because you have
Well, we're always going to have that Davidson for free. But in that particular part, what do you have? What number's coming at you? The percent, I've given you the area. So Alicia's identified it somewhere between these two. So let's just throw it here. I mean for grins, shade this and call it 5%. Our job is to figure out the z-score that makes that 5%, and then convert that down to the scale, and that's what we can tell our moms. Here's the cutoff for preemies. Is that fair? So now we can do it the other way. You can keep guessing at what the number is going to be until you get the 5%, but it's quicker to go this way. It gets you the answer directly versus indirectly. Fair enough? Okay, so I know the area's got to be 5%, and I know it's shaded to the left. That sounds like a still normal problem, doesn't it? Grab your TIs. This is one of those things from 252, Davidson, you can't actually do without technology. You have to do it via approximation.